My name is Sebastian Magana, and today we will be going over the topics of Python and neural networks. So in today's content of this presentation, we will be going over the presentation slides that are centered on today's topics, which are neural networks and universal approximation theorem. We will also be going over two videos on these subjects and going deeper into the subjects as uh, they discussed. And finally, we would also be putting everything into perspective and providing my concluding thoughts to these topics. Neural networks. So, what is a neural network? A neural network could be thought of as a digital replica of the brain, and it processes information by using layers of neurons or nodes. Over time, the network uh, can become smarter as each layer discovers patterns and connections in the data. Uh, so we can consider it similar to how your phone remembers your Face ID or how Spotify can learn your musical preferences. Do they have sufficient functionalities? Neural networks are extremely strong and they are capable of processing natural languages, picture recognitions, and other tasks. But however, they do have limits, such as not always being perfect, like making unusual predictions, and can be slow most times. Examples of this could be like uh it could be used for everyday uses, such as virtual assistants, such as Siri or Alexa. And it is also used in advanced applications such as Tesla's self-driving vehicles that would always learn how to navigate through terrain without having anyone uh, to be driving it. Universal approximation theorem. So, what is the universal approximation theorem? According to this theorem, it is a neural network with a sufficient number of neurons and at least one hidden layer that could estimate any continuous functions. To put it simply, neural networks are such like Swiss Army knives for problem solving. With the correct configuration, they can mimic almost anything or almost every processes. What are some examples of this theorem, you might say? Some examples of this theory could include things such as weather predictions, where the neural networks mimic patterns of temperature, wind, and precipitation. And one other example that of this theorem is the stock market predictions, where the neural networks would examine patterns to predict these prices. Another question that most of you guys might have are, does this theorem have sufficient functionality? Uh, I would say yes, that this theorem does show that neural networks have sufficient functionalities under certain conditions. Um, it states that a neural network with the one hidden layer, enough neurons, and the right activation functions can approximate any continuous functions. This means that neural networks are incredibly versatile and capable of solving a wide range of problems. But however, while the theorem proves their potential, uh, real world challenges like choosing the right network size, training data, and avoiding overfitting can limit their performance. But overall, this theorem does highlights the power of neural networks, but also reminds us that the proper design and optimizations are very important for their successes. So now we will be going over video one. And in this video titled, But What is a Neural Network by Grant Sanderson, He uses the example of handwritten number recognitions to then explain neural networks in a straightforward way. According to him, a neural network is made up of layers, interconnected, quote unquote, neurons, which each of which corresponds to a number between either 1 and 0, or how much a network is lit up. Uh, an output layer produces the final predictions, such as determining what number is printed, after passing through hidden layers that do the processing, and also an input layer that contains the images of pixels. Uh, this video does also speaks about how neural networks can operate mathematically, and just how they're inspired by how human brains process information. But it's a great intro to the foundations of neural networks and how they could function, and also how we could all like learn from it. So now going into video two, uh, the speaker explains that the universal approximation theorem, in this video called Universal Approximation Theorem and Intuitive Proof Using Graphs. Uh, this theorem simply just talks about that if the activation function is continuous, bounded, and non-constant, then any continuous functions may be approximated by a neural network with a single hidden layer and a finite number of neurons. Um, to put it more simply, under the correct circumstances, even a basic neural network could learn to map um, intricate patterns or even like functions. The video also helps viewers naturally get a hold of this concept by using graphs and also visual illustrations. Uh, it shows how the network may represent any continuous functions with sufficient tweaks, even though it may require a large number of neurons. Additionally, the network is able to approximate a function by varying its values or quote unquote weights. And as you can see here in the bottom of the screen, we have an image of how this process would work, which shows the input layers going into the hidden layers and then outputting into the output layer. So after going over everything, all things considered, the theorem and neural networks show how incredible and adaptable these systems are. Uh, these neural networks uh, can learn and adapt to recognize many different patterns in any data. So, and like also functioning somewhat similar to a digital brain where all the information is kept. Uh, they are capable of a wide range of tasks, um, many things, such as including image recognitions, uh, weather forecasting, and even stock market trend analysis, where we would be able to view and get a prediction of how our stock uh, could be in the next few hours or days. Um, they can make mistakes and take a while, but it doesn't really change the fact that they are incredibly strong. And this is made even more awesome by the theorem, which shows that virtually any continuous functions could be mimicked by a basic neural network with just one hidden layer. And in simple terms, neural networks can tackle any problems. So no matter how complex they could be, even given enough neurons and the proper configurations, um, it could be. it can tackle like any situation. It's exciting to see how they're like shaping technology because, well, they could help us solve tough challenges and for us to predict anything about it.